Hi everybody, and welcome to class online. And so we're going to start chapter 6 today, and this is all about solving triangles that are not necessarily right triangles. If we have a right triangle, which means one of our angles is 90 degrees, then we can use the trig functions, which we've been talking about all semester: sine, cosine, tangent, etc. If it's not a right triangle, then we cannot use those trig functions, and so we have to come up with another method to be able to solve a triangle. So if you'll recall, solving a triangle means finding out all the unknown sides and angles of that triangle. Okay, first I want us to this is like our intro to it. I want us to remember kind of maybe in middle school when you were looking for maybe similar figures, or you heard something called congruent figures. With triangles, they would say something like side, angle, side, or angle, angle, side, or side, side, side. If you've heard those terms before, we're about to relive those. Just remember what they are. So here are 3 triangles. They are not special. They're just any triangles. And so I'm just going to talk about how you would mark if something's known. So for instance, on the first triangle, I'm going to mark this side and this side. That little tick mark means that it's known. Those sides, we know what those values are. And I'm going to put this little mark in between this angle, and this means that this side, this angle, and this side are known. And so what I would say here, what I know about this particular triangle is that side, angle, side is known, and so I'm going to do it in this order: side, angle, side. Let's go on. I'm just going to be going through this just so we know how to call these things out. Over here, side, this is what I'm going to put on this guy. Over here, I'm going to do this. Over here, I'm going to do this. Over here, I'm going to do this. Let's see, where did I want that to be? Here. Over here, I'm going to do this. Okay, so what we're going to do is first go through these triangles and just say, what do we know about them? So if we look at this first one, we said, oh, we know this side, this angle, and this side. SAS is what we're going to say there. Right here, we know this side, and this angle. We know side, side, angle. All right. Right here, we know angle, side, angle. Okay. Right here, we know angle, then a side. Right here, we know angle, then a side, then an angle. Right here, we don't know any angles. We just know side, side, side. So that's first how you would identify what you've been given in these triangles. Why this makes a difference is depending on what they give you determines which route we're going to take to be able to solve it. There's 2 laws we're going to learn. One is called law of sines, and one is called law of cosines. So law of sines, which I haven't even told you what it is. Right now we're just deciding when we can use it. Law of sines, this is when you can use it. You can use it to solve a triangle whenever there are 2 angles given. When there are 2 angles given. Or you can use it when there is a side, and an angle given. All right, so let's go through and say which one of these can we use the law of sines for. All right, so I'm going to mark the law of sines in red. So red. So let's see. The rule is if there's 2 angles given, law of sines, or if it's sine, sine, angle. So what you might hear me say is, like, if you spelled this backwards, it would spell sort of a bad word. So if you can spell a bad word with it, that's law of sines as well. So right here, I have only 1 angle given. That's not it. I have, let's see, where can we find 2 angles given? Right here. 2 angles given, angle and angle. This is law of sines. Law of sines can be used right there. 2 angles given. Law of sines can be used there. 2 angles given. Law of sines can be given. Okay, so 2 angles, 2 angles, 2 angles. Law of sines. We can use that. then right here is a case where if we spelled that backwards, it would make a bad word. So this is called law of sines. And this gets a little asterisk by it. This gets a little asterisk by it because this is also known as the ambiguous case. This is a U. Ambiguous case. Meaning that it's not clear if there's 0 triangles that can be formed, 1 triangle that can be formed, or 2. We have to work a little bit harder. This could be 0, 1, or 2 triangles could be formed. So we're going to look at these separately in just a minute. Now, the other situations are when we use a different rule called law of cosines. So when do you use law of cosines? Okay. Law of cosines is what we will use. Law of cosines. You want to use it when, let's see, only one angle's given. Only one angle given or no angles given. That's when we will use that one, law of cosine. So let's go through here and say, oh, which one of those? Here, only one angle's given. This is law of cosines. Here, no angles are given. This is going to be law of cosines. So that was the first step to determine which rule we use when, and I'm going to introduce the rule. So first, on the worksheet, now we're on the worksheet that I gave you, and we're going to use, it's the law of sines worksheet that we start with. We're going to learn how to draw out the angle, draw out the triangle, and then first decide, here's the given information, can I use law of sines? It's example 1. Okay, so let me erase the board and let us begin. Example 1 goes like this. It says, determine whether or not the law of sines can be used here. That's our job. Determine whether or not the law of sines can be used here. So, law of sines. If you can spell a bad word or if 2 angles are given. Law of sines. So, in general, this is the generic triangle I will use. Some triangle I will label this A, this B, this C. Across from angle B will be little b, indicating the length of that side. Across from angle A will be little a, indicating the length of that side. And little c will go across from C. So this is the generic triangle I'll be drawing every time. So, example 1, they say this. They say A is equal to 122 degrees, little a is equal to 5 inches, and little b is equal to 7 inches. Okay, let's draw ourselves a triangle and label what we know. We know that angle A is 122 degrees. Little a, which is across from here, is 5 inches, and this is B, right? And so little b is across from there, and it's 7 inches. So what I have here is a side angle. This is the ambiguous case. We can use law of sines. Yes, we can use it here. All right, that was, I think, A. Here is B. B, they say that big B, angle big B, is 116 degrees. That's a 6. Angle C is 9 degrees, and little b is 10.1 feet. All right, so here's our generic triangle. A, B, C. Okay, let's see, what did they give us? They said angle B was 116 degrees, 116. They said angle C is 9 degrees, 9 degrees. And that little b is 10.1 feet. They gave me an angle, and a side. 2 angles are given. Yes, I can use law of sines here. All right, see? They said this. Little a is 110 yards. B is 81 degrees. C is 91 yards. Okay, so let's draw this guy. A, B, C. Little a is down here, 110 yards. Angle B is right here, 81 degrees. And little c is over here, 91 yards. Here they give me this side, this angle, and this side. Side, angle, side. No, I cannot use law of sines here because only one angle's given and it is not this ambiguous case right here. So that's no. D, what did they give me? They gave me that little a is 6 meters. Little b is 2 meters. And little c is 19 meters, okay? Let's see, let's draw this guy. A, B, C. They tell me little a is 6 meters. They told me little b is 2 meters. And they told me little c is 19 meters. And this is the side, side, side. No, I cannot use law of sines here. Now, let's put the little however. What could we do with these ones that we can't use law of sines here? When can you use law of cosines? If one angle's given, okay, one angle's given here. Oh, we could use law of cosines here. That would work. And here, no angles are given, side, side, side. We can use law of cosines here. All right, so this is just the warm-up, and we're about to do I'm about to start a different video where we dive into solving a couple of triangles.